So today we're going to look at solving equations using multiplication and using division. Same kind of idea as what we were doing yesterday, but yesterday's problems were like t plus 30 equals 7. When we need to get t by itself, we subtracted 30 from each side. We did the inverse operation. So similarly to what we did yesterday, I would like to look at some problems that instead of involving just addition and subtraction, they instead involve, sorry about that, I don't know what happened there. Instead, they involve multiplication or division. So I have t over 30 equals, let's say, 7 over 10. Okay, well, in the past, you've had problems like this, and you've used cross multiplication, and that works too. But essentially what you're doing here, since it's t divided by 30, in order to get rid of 30, just like when we had up here the plus 30 to get rid of it, we subtracted 30. Well, the inverse of division would be multiplication. So in order to get rid of the 30, I multiply both sides by 30, because 30 over 30 is the same as 1. 1 times anything is just that anything, so 1 times t is t. So over here now I have 7 times the 30, which is 210. Then I divide that by 10, so I know my zeros cancel. 21 over 1 is just 21. So t equals 21. And if you had cross multiplied, you would have got the same thing. 10t equals 210. Oops, I put too many ones in there. Divide by 10 equals 21. Let's look at another one. How about if I did s over 12 equals 3 over 4. To get the s by itself, I'm going to multiply both sides of the equal sign by 12. 12 over 12 is 1. 1 times s is just s. 3 times 12 is 36. I have 36 over 4. 36 divided by 4 we know is 9, so s equals 9. Okay, let's try another one. What if I have t divided by 9 equals 8? Same thing, I could rewrite it as t over 9 equals 8. I know I want to get t by itself, so I'm going to multiply both sides by 9. This is gone, I'm left with t. 8 times 9 is 72. And I haven't mentioned this on the previous problems, but once again we know we should always plug them in and check. 72 divided by 9 is in fact 8. Let's look at one that might be maybe a little more complicated. Let's say I have 2 1/4 g equals 1 1/2. The first thing I would do with these problems is I would rewrite them as improper fractions. So in order to do that, you take the bottom number and you multiply it by the big number. So 4 times 2 is 8. Then I add that to the top number. So 8 plus 1 is 9. So I got to keep the denominator the same. So I have 9 over 4. So 9 over 4g equals, I'm going to do the same process. Multiply, then add. 2 times 1 is 2. 2 plus 1 is 3. 3 over 2. And I want to explain why that little process works. I know you might not care, but maybe if I explain it, it'll make more sense. So if I have 2 1/4, well, we've got to have it as a common denominator of 4. You know that 4 over 4 is the same as 1, right? So you have 2, you don't just have 1. So I've got 4 over 4 twice. So 4 over 4 plus 4 over 4. Then I also have this 1/4. So 4 plus 4, notice that's 2 times 4. I've got 4 twice. That's 8 plus 1 more is 9. And then it's all over 4. The bottom always stays the same. So let's go back and look at this. So I have 9 over 4g is equal to 3 over 2. So I want to get g all by itself. In order to get rid of this 9/4, I'm going to multiply by its reciprocal. The reciprocal just means you take the fraction and you flip it over. So I had 9 over 4, now I have 4 over 9. Whatever I do on one side, I know I have to do to the other. So since I multiplied this side by 9 over 4, or 4 over 9, I have to multiply this side by 4 over 9. So what ends up happening, 4 times 9 is 36, 9 times 4 is 36, 36 over 36g is equal to 3 times 4, which is 12, 2 times 9, which is 18. Now, we know that 36 over 36 is just the same as 1. 1 times g equals 12 over 18, which both of these I can see are divisible by 6. So 12 divided by 6 is 2. 18 divided by 6 is 3. So this reduces to 2/3. 1 times g is just the same as g. So I have g equals 2/3, and that is my final answer. So let's look at one more time what we did here. I've got 2 1/4 g is equal to 1 1/2. First, I converted it to an improper fraction. So I had 9 over 4g equals 3 over 2. To get rid of this, I multiplied by its reciprocal. So these cancel each other. They don't really cancel, they become 1, but a lot of teachers just say they cancel to make it simpler. I just like for you to understand the math behind it, I guess. So g equals, let's see here, 3 times 4 is 12, 12 over 18, which we simplified into 2 over 3. Which is what our g is equal to. So that's how you solve problems that involve fractions. That was a multiplication problem. Now let's look at one that is multiplication, that instead of using multiplication, we're going to instead have to use division. So if I have 42 equals -6 times m. We know the inverse of multiplication is division. So in order to get rid of this -6 that's here in front of the m, I'm going to divide by -6. So 42 divided by -6 is -7. So m is equal to -7. And if you plug it back in and check it, it makes sense. -6 times -7. We know a negative times a negative, multiply or divide, it's an easy thought. Same signs are positive. So a negative times a negative makes a positive 42, which is what we had to begin with. Let's try another one. If I have negative 15b equals a -75. Okay, this is the same as having 15 times b. So to get rid of it, I divide by -15. Okay, so these are gone. I'm left with b. Negative divided by a negative, I know my answer is going to be a positive. And 75 divided by 15, well, let's think about it. 15, 30, 45, 60, 75. So it is 5. B equals 5. Okay, if I'm looking at 13s is equal to 195. Okay, I want to get s by itself. Once again, it's being multiplied by the s here, 13 times s. So in order to get rid of 13, I'm going to do the inverse operation, which is divide. 13 over 13 is just 1. 1 times s is s. 195 divided by 13 is 15. Plug it back in and check. Is 13 times 15 equal to 195? Yes, it is. So that works. Okay, let's try another one. Negative 3x equals 12. Now, I've seen kids a lot of times want to add 3. and that is not what we want to do here. This isn't saying if I added 3, first of all, they're not like terms. I can't add 3 to the negative 3x. That does not work. Don't confuse this sign as being subtract, so then you think, oh, well, I got to do the inverse operation. I've got to add. Instead, realize that this is saying negative 3 times x equals 12. In order to get rid of this, I've got to do the inverse operation. So the opposite of multiplication is division. So I divide by negative 3. Whatever I do on one side of the equal sign, I must also do on the other. Negative 3 over negative 3 is just 1. 1 times x leaves me with x. A positive divided by a negative. Remember our song, multiply or divide, it's an easy thought. Same signs are positive, but different signs are not. They're not positive, therefore they must be negative. 12 divided by negative 3 is a negative 4. Plug it back in and check. Negative 3 times negative 4 does in fact equal, a negative times a negative makes it a positive, so it is a positive 12. Okay, now I would like to look at a problem where you have to convert it from words into an equation and then solve it. So let's say that the problem says negative 18 times a number equals 198. So a negative 18 times a number. So if I times a number, the unknown here is that number. We don't know what that number is, so we're just going to let it be represented by n. So negative 18 times n equals negative 198. Now, how would I solve for n? This is negative 18 times n, so I'm going to do the inverse and divide by negative 18. Negative over negative becomes a positive. That's 1. 1 times n is just n. Negative 198 divided by a negative 18. A negative divided by a negative makes it a positive, and it is 11. Plug it back in and check. It works. Negative 18 times a positive 11 is negative 198. Okay, what I would like for you to do for the remainder of the period is work on page 138, and I want you to do numbers 13 through 30. You can do all of those. Remember to check your odd answers in the back of the book and show your work. If you do not show your work, you do not get credit. So it's very important. It's useless to do it unless you show your work. So you're doing numbers 13 through 30 on page 138.